Alright, welcome to my YouTube channel. So in today's video, we're going to be looking at some special problems, and this is actually going to be a beginning of this section, in our videos, that at the end of the treating of any topic, we would take time to look at some special problems. That's what we call word problems, and some other special aspects that would involve the application of the topic that have been treated. So we are going to start some special problems that will allow us solve such kind of problems. And so we're beginning that in this video, and this is on sequences and series. We just concluded our lesson on the sum of the first n terms of an arithmetic progression. And so this is an example. So it says that assuming we are given the sum of the first n terms of a linear sequence. Remember, I said a linear sequence is also called the arithmetic progression. Is given as 1 plus 9 n squared. So we have that the sum Sn is equal to 1 plus 9n squared, and they are asking us to find the 20th term. Now you're only given the sum of the n terms, that's the first n terms, and you're asked to find the 20th term. So that means you are asked to find T20. Okay, so and now you recall that I once talked about a relationship between the Sn and Tn, and if you recall properly, I said that Tn is equal to Sn minus Sn plus 1, and I gave an example to buttress that, which you can always look at. For instance, let's assume we have a sequence, say 3, 4, let's even just use this 5, 6, the normal counting numbers. Okay, so you would see that this is an arithmetic progression where the difference is 1. Okay, so assuming I increase this to 7, 8, 9, so if I say we should get the sum of the first two terms here, you're going to have 7. That means S2 is equal to 7. But S3 is going to be 7 plus 5, which is 12. So the only difference between this is just the additional third term. So since this is the T3, you will see that T3 is just equal to the sum of the first 3, which is S3, minus the sum of the first 2, which is S2. Okay, and so that's where we got this. And so this is the formula we're going to apply to be able to solve this. Okay, so let's look at that. Now, Sn is given at this as this. So can we find Sn minus 1? So what would be our Sn minus 1? Sn minus 1 would just be a substitution of n as n minus 1. So anywhere we see n, we remove it and put n minus 1. So if we open this bracket, we'll have, if you square this, that will give us n squared minus 2n plus 1. Okay, and then that will give us 1 plus 9n squared minus 18n then plus 9. Okay, so this is our Sn minus 1. So if we bring that now to this equation, so it means that our Tn is going to now be the 1 plus 9n squared minus Sn minus 1, which is the whole of this, 1 plus 9n squared minus 18n plus 9. Okay, and that's our Sn minus 1. So if we open our bracket here, we'll have 1 plus 9s squared minus 1 minus 9s squared plus 18n minus 9. And what would that give us? 1 will take away 1 here, 9s squared will take away 9s squared here. So we are going to have that our Tn alone is equal to 18n minus 9. And so if we have gotten our Tn, so it is easy then to find our T20. So that means our T20 is simply equal to 18 times 20 minus 9. And this is going to give us 360 minus 9, which is equal to 351. And that's the solution to this problem. And that's the only problem I would like us to solve in this video. And then subsequently, we're going to look at other examples that involve application of the topic that have been done, and then word problems and other problems very critical to the concepts that we've learned. So thank you so much for watching. Kindly subscribe to our YouTube channel. We'll see you in our next video. Please comment, like, and share our videos. Bye.